Very important problem, because in this problem you'll get to know what is actually how to apply limiting frictional values. Now there are two systems. See, one is 3 kg, one is 2 kg, right? It's not necessary that always the force is large enough to conquer the limiting frictional values. For example, in on this 2 kg, what is the frictional value, the limiting frictional value we are writing is L for limiting, right? Mu mg, right? 0.1 into 2 into 10 mu mg, right? That is 2 Newton. And for B, the limiting friction is mu m of B, that is 3 into 10, that is 6 Newton. That means the net force on the right hand side on this body should be greater than 6 Newton, then this is in a position to move. And on the other hand, the net force on the left hand of this body A should be greater than 2 Newton, the net force, then it is about to move. So if the net force is not greater than 1, greater than 2, this will not move. Okay, so let's draw the free body diagram. Free body diagram of B. Okay, this is B, this is F2. F2 equal to how much? F2 equal to 8 Newton. But there is a force which is tension, right? And there is a frictional force also, FB. Alright, let's go to A. What is the frictional force? What is the frictional force? If this body is going probably in this direction, the frictional force will act in different directions. So this is FA, T, and there is F. F is how much? 1 Newton. Okay. Now the maximum value of FA is 2 Newton, right? So the maximum force which can withstand this T is 3 Newton, right? Because the maximum value of FA equal to 2 Newton, the maximum. This is the limiting value equal to 2 Newton. So T has to be greater than 3 Newton so that this body is moving. So let's come back to this body B. I am saying that whether it's possible that T is greater than 2 Newton, 3 Newton. So T max, sorry, T not max, I beg your pardon, T min. The minimum value of T should be 3 Newton. Oh, so sorry, okay, it's not maximum, it's minimum. So minimum value of T should be 3 Newton so that this body, this A, is in a position to move. So the minimum value of T is 3. Is it possible for this body? The answer is no. Because if T is minimum 3 Newton, okay, then the maximum opposing force contrary to this F2 is 3 plus 6, that is 9 Newton. That means this body will not move. Let me repeat it, that if the minimum value of T is 3 Newton, the total opposing force over here is 3 Newton plus FBL, 6 Newton, is 9 Newton over there, which is impossible because the maximum value over here is 8 Newton. This body cannot go in this directions. So what is the only possibility? That the only possibility is that this FB will attain to maximum value. That means this will attain to 6 Newton. Okay, all right. So if it is 6 Newton, then what is the value of T? The value of T must be equal to 2 Newton so that this body is not moving at all. Okay, come back to this point. T is how much? T is over here is 2 Newton because it's the same thread. The tension will be same over here, same over the whole thread, right? So the value of T is how much? 2 Newton, and there is 1 Newton force in this direction, in the opposite direction. So the frictional force cannot go up to the limiting value. It will be lesser than limiting value. The limiting value is 2 Newton, but in this particular case it will be, to maintain the equilibrium, it must be equal to 1 Newton. Okay, so this is the thing, that both the body will not move at all, and the frictional force in this particular case, in case of A, will not go up to 2 Newton. I am leaving this to the students, that why I am taking the maximum frictional value over here, not over here. Why you did not try? Please try it in home, that why we did not try it with 2 Newton and ending up going over there. Why it's going into limiting value, not this one. Okay. Now let's come to the second stage of the problem. Okay. Let me get some space. Oops. Okay, let me get whatever space is possible without messing it up. Okay, oops, again and again, sorry about that. Okay, I'm not, just ignore this part. Okay, now the second part. Okay, this is even easier actually. So I'm telling, before going to the second part, I'm telling you a shortcut. Okay, how to know. Okay, first of all, the total force, total opposing force, the total limiting value of FAL and FLBL is 8 Newton, and total force over here is 8 plus 1 Newton, that is 9 Newton. Okay, not sorry, 8 minus 1 Newton, right? Because F1 and F2 are applied in a different direction. So the total force in this direction is 7 Newton. Are you getting my point? Because 8 Newton in this directions and 1 Newton in this direction. So this is 7 Newton. So since this force is less than this total opposing force, this system will never move. Okay, that is the shortcut. Okay, you can apply that just without solving this much. You can directly say that you have to find out the total limiting value of the forces is 8 Newton, and don't bother about the directions of this. Okay, because friction can act in this direction and this directions also. So total maximum limiting force is 8 Newton, and the total applied force is 7 Newton over here. So since 7 Newton is less than 8 Newton, this body will not move. Now come to the second point. Okay, the net force is how much? F2 minus F1 is 12 minus 3. 12 minus 3 is equal to 9 Newton. 9 Newton is greater than 8 Newton. So these bodies will move. So now we can directly go to the problem and solve it. Okay, come to this. Okay, B, this is B again. So the force is how much? 12 Newton. Since the body is moving, we can say that they have definitely attained the maximum or the limiting value of the frictions, that is 6 Newton. So there is a T over here. The body is moving in this directions with an acceleration of A. So what we can write? 12 minus 6 minus T equal to 3A. Okay, come to this point, 2 kg. The free body diagram is this. There is a T and there is a F. F is how much? 3 Newton. Thus this body is also moving in this directions with an acceleration of A, and obviously since the body is moving, it is attaining the maximum frictional force, that is 2 Newton. So total how much opposing force is there? 5 Newton. So what we can write? T minus 5 Newton equal to 2A. Okay, so obviously we can I mean, you need not to write Newton, that is confusing. I'm just writing 5. Okay, so T minus 5 equal to 2A. Just add this 2. This is equation number 2. Just add this 2, you will get the answer. This is 6 minus T equal to 3A. Okay, so if I'm adding this 2, what I'll get? 1 equal to 5A. So A equal to 1 by 5 meter per second square. This is the answer. That means these two bodies will move. A with an acceleration a 1 by 5 meter per second square. Thank you.